So 8.7a, conic section, circles, and parabolas. And we're going to start out with the distance and midpoint formulas. And we're looking for distances. That's going to be labeled D. So if we're looking for the distance between here and here, or possibly we're looking for the point that is halfway between these 2 points. So follow along this line and stop here. I'm not interested in how long it is. I'm interested in the coordinates. So like if this were over 4 and up 3, that's what I'm looking for, is where that point is right there. So maybe it's 3, 2. Okay, so maybe to get there I had to go over 3 and up 2, and that's what I'm interested in, is the coordinate of that point rather than how far that point is away from either end. Alright, so let's look at this picture, because they're going to use a lot of these crazy letters to figure this out. Okay, the distance from here to here, which is how far this point is along the x-axis, is called x1. Okay, the distance from here to here, they're calling x2. Okay, so x1 is this point, x2 is this point. The length of this would be the difference between this number and this number. So let's say, for instance, this was 3 and this is 6. Okay, so x1 is 3, x2 is 6. That means the distance between here and here would be x2, 6, minus x1, which is 3. 6 minus 3 is 3. So the length of this line would be 3. The same is true if you look at the y-axis. They give us a y1 value. In order to get here, we had to go over x2, right here, and up y1. And that's the distance right here is y1. To get here, we had to go over x2, the same as here, and up a certain distance. We'll call it y2 because it's a different point than this one. So this distance from here to here is how far it is from here to here minus how far it is from here to here. Okay, so it's the difference between the entire length and getting rid of this part. So we're just interested in this. And they have the absolute value signs because distances are always positive. So you're going to have, whether that's a positive or negative number, you're going to get a positive answer for your distance. Alright, so the distance between here and here would be D. Okay, and this is basically Pythagorean theorem, and they've just kind of made it a little bit different. They did a lot of the work for you. And so then we've got the absolute value of x minus x1. Okay, and then they square it. Remember, Pythagorean is a squared plus b squared equals c squared. And c squared is your hypotenuse. And in order to find this, we took the square root of both sides, and then that just means we're looking at c. So that's where this radical came from, and our exponents came from there. So just kind of giving you a heads up on what's going on there. All right, let's continue on with this formula, this distance formula. Plus absolute value of y2 minus y1 absolute value, and that's squared. So that is going to give you the distance d, the hypotenuse. And that's just a real simple formula for you to use in order to find that. In fact, the distance between this point and this point, the book gives you, they just take out the absolute value signs basically. x2 minus x1 quantity squared plus y minus other y quantity squared. So that is considered the distance formula. Okay, so example 1 says find the distance between these 2 points. Okay, so we could draw our line here and go over 3 and up 2 and over 1 and down 4. And they're interested in the distance between those 2 points. Alright, so we don't even have to draw the graph in order to do that. We just use our distance formula. And we know that our first term is an x, our second term is a y. So we can say d equals the square root of Well, which of these x's is x2 and which one is x1? Doesn't matter. Let's just use this as our x2 and this one as our x1. Which means if we used this as our x2, we have to use this one as our y2. Okay, so distance equals radical -3 minus 1 is -4 plus 2 plus 4 is 6. So my distance equals the square root of 16 plus 36, which equals the square root of 52. Now remember, you can't be done with the square root of 52 unless you find out if it can be reduced. So what we're going to do is we're going to factor it into its product of primes. Let's see, that would be 13. So we've got a pair of 2's here. It matches up with our index here. So if we have a pair, doesn't have anything to do with the number that we have here. This 2 doesn't have anything to do with, that. All I'm looking at is I have a quantity of 2 and my index is 2. When that's the case, I can take whatever I have a quantity of 2 out and left with everything that's a quantity of 1 left in there, and I have 2 square root of 13. Alright, so B asks you another question. We're not going to go into that question, but what it asks for is use the distance formula to show that A, B, and C, all 3 of those points, if we were to have a graph here, that all 3 of those points lie on the same line. Okay? That's all they're asking for, that they lie on the same line. Well, how do you know that? Well, the shortest distance between 2 points is a straight line. So if we find out the distance of that and the distance of that and add them together, it better be the same length as that. Okay? So that's what we'll do. We'll use the distance formula to find the distance between A and B, the distance formula to find the distance between B and C, and then we'll find the distance from A to C. If these two add up to be equal to that distance, then they're on the same line, and in this case, yes, it did. Alright, so next part of this section is the midpoint formula. Midpoint formula is, gosh, it was one of those things that you learned back in, I don't know, maybe 8th grade, but for sure 9th or 10th grade. And the midpoint formula is the coordinate of x plus, well, let's put 1 plus x2 to show 2 different x's there, divided by 2. And this is going to be the same thing, only with the y's, divided by 2. That is going to be the midpoint. So if we have 2 points, 3, 6, and 5, -2. Alright, and we have this graph here, and let's say that 3, 6 is here, and 5, -2 is here. What I want to know is the coordinate of that point that's halfway between them. Okay, so that's what I'm looking for. Just wanted to graphically show you what in the world we're doing using the midpoint formula. So these are our points. So I'm going to take one of my x's, add it to the other one, divide by 2. That's this part. And then I'm going to take my y's and divide by 2. So 8 over 2 is 4. 6 minus 2 is 4 over 2 is 2. So that point right there is the halfway point between these 2 points right here. Okay? Okay, this next section has to do with circles, and the definition of a circle is a set of all points, which is all these points here, set of all points in a plane that are equal distance from the center. And this is called a fixed point. So all of the points are the same distance from the center to here. Okay, so we use the distance formula, and we can come up with an equation of a circle that way. So for instance, we can have, actually, let me draw this. Okay, so we can have a distance formula, and we can find out the length of this and this, square it, take the square root, and we can use the radius here. Okay, so they use a formula that uses, for the center point of the circle, for the x value they use the letter h, and for the y value they use the letter k. That's the coordinate of the center point. Now any point on the circle is called an x and a y. Okay, so the formula for a circle, the equation for a circle, is a point on the line minus the x value of the center plus the y value of that point on the line minus the y value of the center, and that equals r squared, r meaning the radius from here to here. Okay, so if we're trying to find out how long the radius is, we can use this formula right here. And the way this formula right here works is, let's go ahead and put a point on the circle. Okay, so that point on the circle, it means that we have 2 points. We have an x and a y, and an h and a k. So x minus h, quantity squared, y minus k, the quantity squared, equals the radius squared. And to find the radius, then remember, all you do is take the square root of that, and it takes the radical off there. Okay, so let's go ahead and look at an example. So let's see if I can get rid of everything except my my circle. Probably can't. Alright, so it says write the equation of the circle with the center at -3, 4. So that's the center. So that means, actually, this is A, H, and that's K. Okay, what else do they give us? Radius of 5. Okay, so remember my formula for the circle was x minus h, quantity squared, plus y minus k, quantity squared, equals r squared. So all I'm going to do is fill in my h and k with my -3 and 4, and my r with my 5. Okay, they already gave me pretty much everything I need. So x minus my h is -3, and that's squared, plus y minus 4 squared equals 5 squared. So x plus 3 plus y minus 4 equals 25. There's my equation. That's all they wanted me to find there, so not too terribly difficult to do that. Alright, so let's find the equation of the circle for example 3, but this time they're giving us as our center 3, -1, and instead of giving us the radius, they're giving us a point on the circle. Okay, so we've got our, let me get a circle on here. Okay, so that's what they give us. Here's my Cartesian plane, my xy axis, and the center is over 3, down 1, and a point on the circle is over 4, up 6. So that's the information they gave us, and they're asking us to find the equation of the circle in that place. Alright, so what we're going to do then is we're going to use our formula to find radius, because we need, in order for us to solve this, we need the r value. We also need our h and k value. So our r value is, or our equation, is going to be our x value and our y value. Okay? So I just took my 2 points here. So instead of having the radius like I did in the last one, I have my 2 points. So r equals the square root of 1 squared plus 6 plus 1 is 7, 49, equals the square root of 50. Okay, so that's what my r value equals. Okay, so my formula, though, if you remember right, is x minus h, quantity squared, plus y minus k, quantity squared, equals r squared. So I've got to square that in order to put that here. And then I've got x minus 3 plus y plus 1 equals 50. Okay, so the only thing I really found doing all of this work here was just to find out what the length of the radius was, the distance here from here to a point on the circle. So that's what all this work was for, is just to find out that the radius is the square root of 50. Then I squared it, which means take off the square root sign. This 3 and this 1 were from here. Okay, those are the centers, h and k. So those were already given. Anyway, so that's it for example 3, and I'll shut this down and we'll start the next video.